Hi folks, I'm Karthikeyan Chandrasekhar, working as an assistant professor, the Department of Electronics and Communication Engineering from R.M.K. CET. Today, we will be discussing about Introduction to VLSI in Chapter 1 under 21 EC 503 VLSI Design for the 5th semester 3rd year students. So VLSI is an acronym of Very Large Scale Integration. Outline: what is VLSI? Why VLSI we need? Where is the demand? What roles to be chosen? How much rewarding can be? How to get chosen? Where to start? How to deal with the VLSI circuits? And the career opportunities for freshers? What are the advice with respect to internships? And conclusion. Now, integrated circuit. So a circuit which have many combinations of both active as well as passive devices is put together on a single IC. We call it as integrated circuit. I again repeat, a chip which encompasses of both active device and passive device is called as integrated circuit. Let me have a quick recap of the technology available based on the number of transistors. So the technology has been classified into the following types: small scale integration, where the transistor count ranges from 1 to 10; medium scale integration, the transistor count is from 10 to 500; large scale integration, the transistor count is from 500 to 20,000; very large scale integration, which is a technology in our course, so it is more than 20,000 to 10 lakhs count of transistors. More than 10 lakhs, it comes under the ultra large scale integration. The main objective of designing an efficient VLSI system has high circuit speed, low power consumption, and designing the area which is portable and which have less area. The advancement in technology. So we can see in the year 2005, SanDisk is a company which produces 128 megabyte of storage device in the pen drive. Later, the 2014, we can store 128 GB. Later, we can store 64 GB as well, and now we can store 1 terabyte. The same SanDisk company have reached now to 1 terabyte from 128 megabyte in the year 2005 till 2023. So the advancement is only because of VLSI technology. VLSI design flow. First, we need to know the problem. We have to get some idea. Based on the idea, specifications need to be jotted down and the design architecture need to be designed. RTL coding, RTL verification. RTL is an acronym of register transfer level logic. Next, synthesis. The next step is foundry, and the last step is IC chip. First comes the ideas. So we need to know the basic microprocessor, microcontroller, memories, printer, mobile, and digital security lock. So for example, the laptop what we are using, if we use for a long time, the heat has been generated is a problem. For that problem, we need to come up with an idea. For that, we need to know what microprocessor and about its specification, what microcontroller. It is an Intel 8085 or Intel i3 configuration, i7 configuration microcontroller, which is nothing but a processor which have memory together as inbuilt. Memories, whether it uses RAM, 512 GB or the capacity of ROM, all such kind of stuff need to be known. Whether the peripherals has been connected, printer, mobile, and digital security lock. Specification. We need to know the instruction set and we need to know about the interfacing, what are the input and output pins of a specific processor, organization of the system, and this is the one which is a very important step as it will majorly affect the future of the product while designing, and the specification plays a vital role. Design architecture. Design architecture where we will be using some EDA tools like Synopsys, Active HDL hardware description language, Xilinx ISG, Cadence. And a display is being provided here where we will be having some logic gates with the flip-flop. Next, RTL coding. For this, we need to know about the hardware description language like VHDL, very high speed integrated circuit hardware description language, Verilog, system Verilog. And the RTL coding tools, register transfer level tools are Xilinx, VIM, Emacs, Context, HDL Turbo Writer. Next, RTL verification. Once we develop the code, it has to be verified logically. For that, some verification tools are ModelSim, Xilinx ISG, Verilog Excel, FinSim, Test Builder. Sixth step, it requires synthesis. The synthesis tools are FPGA, especially Xilinx, Ultra, Digiland, or Complex Programmable Logic Device CPLD, Ultra, and Digiland. Acronym of FPGA, Field Programmable Gate Array. Synthesis is a process where we are going to convert that register transfer level into logic gates. So transistor level to logical level. Then FPGA kit, so we will be having at the boundary input block and the output block, and each cell has CLB, configurable logic block, and it has been connected to the neighboring cells with the help of programmable interconnect. So a physical appearance of Xilinx Sparta is being displayed over here. So it is a IC in which it can be programmed by the user to capture the logic, and it has the capability to capture 1 lakh designed logic gates. The next one is foundry, how a wafer has been formed from silicon by going series of fabrication steps, and at last it is being packed and then metallization is required. So we will get an integrated circuit, a chip. The fabrication process that starts from sand to silicon, it will be molten, and with a series of steps we will be getting a wafer, and it has to move to the last process of aluminum metallization and packaging. Hence we will get an integrated circuit. Where the applications of VLSI? So it has been used in aerospace, automotive electronics, medical electronics, consumer electronics, wireless and wireline, EDA, electronic design automation, MEMS, micro electrical mechanical system, bioelectronics, defense. In most of the industries, the VLSI is being greatly used. And the scope, it has a wide opportunity with respect to fabrications like Samsung, GF, Taiwan Semiconductor Company, electronic device automation, Cadence, Synopsys, Mentor Graphics, design like Intel, Qualcomm, job profiles, design that is with respect to AMS, mixed signal engineer, analog mixed signal, library developer, memory input output designer, register transfer level designer, verification, front end and back end, EDA, design automation tools, software engineer, application engineer, product engineer. So here the list of VLSI companies in India. Some few are Xilinx, Alliance Semiconductor, Cadence, Synopsys, Mentor Graphics, Moschip, Qualcomm. So these are the companies that are available with respect to VLSI domain in India. Thank you.